Okay, so we're going to take a look at the second part of section 1.3. And we're going to start by looking at a function called the greatest integer function. So as the name says, the answer that you get from this function is always an integer. And the way it works is if I give you a number, you give me back the biggest integer you can that's less than or equal to the number I gave you. That's called the greatest integer function. It's the biggest integer you can think of that's less than or equal to the number that I give you. In our book, it uses a symbol for it. I'm probably going to use the symbol on the graphing calculator, which is spelled out INT, int. So let's say I said this. What's the biggest integer you can think of that's less than or equal to 4? Check. 4. Yeah. What's the biggest integer you can think of that's less than or equal to 3.9? Yeah, 3. So what happens in the integer function is it kind of jumps all of a sudden. 3.9, 3.95, 3.96, 3.97, those are all 3. Then all of a sudden you get to 4 and it jumps up. How about what's the greatest integer you can think of that's less than or equal to 4.5? Yeah, 4. And this is kind of how postage works at the post office. When you go to mail something, if it weighs if it weighs like, let's say, 2.1 pounds, you got to pay for 3. If it weighs 2.3, 2.4, 2.5, 2.6, you still pay for 3. If it weighs 3 pounds, you pay for 3. If it weighs 3.1 pounds, it jumps up to 4, you got to pay 4. So that's kind of how that works.
Isn't this the floor function?
Yeah, you could think of it maybe as kind of like a floor or ceiling, depending on how you think about it. But yeah, and that's what the graph of it looks like. So you pick an integer between 2 and 3, including 2. And the y value always comes out to 2. Greatest integer of 2.2, 2. 2.4, 2. 2.9, 2. Then all of a sudden you get to 3, and it jumps up. So the reason I use the open circle and closed circle on that graph is because the closed circle includes the value. The open circle, like right when you get to 2, you're not on this line. You've jumped up to the top one. And sometimes it's called a step function because it kind of looks like a series of steps. So to graph that, if you go to your y equals screen, press the math button. Once you press math, you're going to go over to the number column at the top. And the 5th option down says int. That's the greatest integer function. And then just press X. You don't have to close the parenthesis, but it is a good practice to get used to closing whatever is opened. I didn't open this parenthesis, it put it there for me. So you should have something like that on the screen. INTX. So that was under math, number, and it was the 5th option down. And if you do zoom 6, it won't quite do it as nice with the open and closed circle. The calculator doesn't do that. But it does look pretty much like what I had on the board. So what's the domain of this function? What numbers are you allowed to fill in right there? Yes, yeah. So infinity could be like the highest thing you could plug in. So I'm looking. So when you describe a domain, you have to tell me like a low value and a high value. Yeah, negative infinity to infinity. This is basically all real numbers. You can find the greatest integer function for any number you want. So you can fill in anything you want. But what kind of answer does the function always give you? What type of number do you always get back from it? Yeah? An integer. So the range in this problem would be integers. And you'd have to write that in words. There's really no way to describe it other than to say the range is all integers.
What about in set notation?
You could describe it in set notation, like the range is all values such that the range is all x values such that x is an integer. You could write that in set notation. Yeah.
But we're not doing that.
Yeah, I'm not going to get into that, but you could. That would be a more formal way to write it. We kind of already did that. So find a complete graph of the integer function and then determine the domain and the range. Well, I just asked you that. The domain was all real numbers. You can plug in anything you want. And the answer that you get back from it is always an integer. You don't get back decimals or fractions in this function. All right, let's try another one with domain and range. Just kind of did this a little bit last time, but just to review it. Let's do 16x minus x cubed. Do you think that's a good window to be able to see everything that's happening? How about, wait a minute, what do you think? No. What do you think I probably need to adjust to see this one a little better?
The y-axis.
Yeah, I would adjust the y-axis a little higher and a little lower, just so we can get a complete graph. I'm just going to guess like negative 35. Whoops, except do it on the y-axis. Let's try like, I don't know, even negative 40 to 40. My goal is just, can I see the top and the bottom of those terms? That's good? That looks good? Yeah, that's perfect. So to find a complete graph of this one, I would say that's a good window. Write down those mins and maxes for x and y. Okay, so that's a good window. Let's look at the domain. 16x minus x cubed. Does that function have any fractions in it with variables in the bottom? No. Does it have any square roots in it? What do you think? Megan, what do you think? Any square roots in that one? No. So what do you think the domain is then? Well, Clover, what do you think? What do you think the domain is? Yeah, you can take any number you want and cube it. You can take any number you want and multiply it by 16. you'll never get an error like dividing by 0 because that doesn't come up here. So the domain is all real numbers. Now let's go back and look at the calculator and look at the range. How high and low do you think this graph goes? Yeah, forever. So what would you say the range is? Yep, that's also all real numbers, negative infinity to infinity. So this graph goes up and down forever, and it will go left and right forever. Any question on that one? Yeah.
I need help with my calculator.
With your calculator?
Yeah.
Yeah, what's going on? Yeah, type it in on a different one. Try typing it in on the bottom, like go down one and see if it does. Go to YT. And then the fifth one, X. Try it now. Yeah, so that's better. Okay, so somebody noticed when they typed in the integer function, it connected everything. Okay, it's not supposed to look connected. It's supposed to look exactly, well, if I do zoom 6, it's supposed to look like those horizontal lines. They're not supposed to be connected. If your calculator is connecting them, it's probably because something is just turned on that's different than mine under format. So there's this detect asymptotes under format. We generally want to leave it on. Okay? If you turn it off, it's going to connect those stairs. It shouldn't look like that. Okay, my calculators, it should already be set, but that was yours, so it could be just a different setting. Okay, so I'm going to go back to second zoom, and I'm going to put it back the way it was. Yeah?
For the domain and range, does it matter how you write it? Like, if I don't use the brackets and the parentheses, but use like y equals or less than or equal to?
So yeah, it depends on how they want it. If they ask for interval notation, this is interval notation. If they ask for an inequality, then you could say something for the domain like this. That's the same thing, but that's just, that would be an inequality versus an interval. Just like that. And the third way they could ask for it is a graph. Okay, they could ask you to graph the picture. All right, let's try this one. So we're going to do a few different kinds of problems involving rectangles. Area and perimeter formulas might come up. I think this one, area, is definitely going to come up. So it says we have a pool that has dimensions 30 by 50. And we're going to put a sidewalk, okay, all the way around the pool. And the sidewalk is going to be the same width. Okay, same width, all the way around. We don't know the width of the sidewalk. That's what we're going to end up finding out. But the area of the sidewalk is 600 square feet. Okay? That's all the information they're going to give us. And then they'll ask the question. Find the width of the sidewalk. Okay, a lot of words there. We talked about different approaches to solving a problem. What kind of approach do you think would help us to see what's going on better in this problem? Yeah? Yeah. We should draw this one out. Okay, so we'll draw it out and see if we can get a visual of what's happening. First thing I need is a pool, 30 by 50 feet. Okay. So let me make a pool. There's my pool. And it's 30 feet by 50 feet. So that's going to be 30. That's going to be 50. Okay, so I need my pool. The next thing I need is a sidewalk going around the pool. So to draw that, I'm just going to do another rectangle outside the pool. Try to make it as equal as you can, and then that's the sidewalk going around the pool. How do they want me to represent the width of the sidewalk for now? Yep.
Maybe X.
Yeah, they say let the width of the sidewalk is going to be X. Okay, so that distance, I don't have to write it everywhere, but the width of the sidewalk all the way around is X. And the area of the sidewalk is 600 square feet. What else do we know that they didn't give us? It's something we can calculate based on the numbers we have. Yep.
The area of the pool.
Yeah, we can find the area of the pool. We'll see if it comes in handy. I think it will. But we can definitely find that. Area is 30 times 50, which is going to give me an area of how much? 1,500. Yep. Okay, so I know the area of the pool. I also know the area of the sidewalk. That was given. The problem is the sidewalk is kind of a weird shape. It's like it's this area. It's just the part that's in green. So I'm just going to make that rectangle a different color so I can. I wanted to make it a different color. Fill color, line color. There you go. Does anyone have an idea how I could set up an equation where the area of the sidewalk would be on one side, and on the other side would be a calculation to find the area of the sidewalk using the shapes that I have on the board? How could you find the area of that region that's shaded in red? I mean, we know it's 600, but let's say could I do something with the blue rectangle and the black rectangle to find the area of the red shaded section? Yes. Matt.
Can you add them?
Add the area of the blue rectangle and the black rectangle. Okay, you're on the right track. Yeah.
So you could find like the whole area of the blue, including the pool. And
Okay.
Minus
So we could just say, let's say the area of the blue rectangle, and what did you say to minus?
the pool.
The area of the pool, yes. If you take the area of the big blue rectangle and cut the pool out, you're going to be left with the area of the sidewalk. So this is what we need to set up as an equation. Okay, let's start with the area of the sidewalk. What's the area of the sidewalk?
Oh, it's just this.
The area of the sidewalk is 600. Now, the area of the blue rectangle. What did we say the formula is for area of a rectangle? About Holly? Length times width. What's the length of the blue rectangle? won't be, and it's gonna have numbers and letters, because we don't know exactly, but we can come up with an expression for the length, yeah?
It would be 2x plus 30.
For the length,
Or 50 plus 2, or 2x plus 50.
yeah. So the blue rectangle, we know it's 50 from there to there. Okay, because that's the part where the pool is. But then it has a little bit more on the left and on the right, and that's the sidewalk. So this part is x, this part is x, and this part is 50. So the length of the blue rectangle is 2x plus 50. And I think you kind of already said it, Lucas, what's the width of the blue rectangle?
2x plus 30.
2x plus 30. And the area of the pool, we already know that's 1,500. All right. So now we just have to solve that equation, and that'll give us x. All right, so we got 600. Okay, remember we need to FOIL out the length times width. Nick, what's 2x times 2x?
4x squared.
Yep, 4x squared. And that's going to give me 60x plus 100x. So plus 160x. And 50 times 30 is 1,500. Well, we had a plus 1,500 from foiling it out, and then we had a minus 1,500 for the area of the pool. So what kind of equation are we left with right there, since the highest exponent is a 2? Do you remember what that's called? Well, if the highest exponent was a 1, it would be linear. When the highest exponent is a 2, it's what kind of equation? Yep.
I'm waiting for other people.
You waiting for someone else?
I've taken everyone else's opportunity, so.
So it's a parabola, but what kind of equation graph, when you graph it, looks like a parabola? Yeah, you think you know that?
I think that I'd have to guess, because I'm just going to guess because I was going to read it all day. Is it, you mean like the shape of the parabola would be?
Yeah, what equation has an exponent or a degree of 2?
Would it be a U-shaped parabola?
Well, yeah, all parabolas have that kind of shape to them, but this is more what the equation is called, yeah?
Is it quadratic?
It's a quadratic. So we're either going to have to use quadratic formula or factoring, or we could do graphing, either way. But whenever you're trying to solve a quadratic, what do you always have to get it equal to? What is it? Yep, you got to get it equal to 0. So I would put everything on the left side. And you don't have to, but everything is divisible by 4, so that'll make the numbers a little easier if we divide through by 4. Right, and I'm going to use quadratic formula because I don't know if that's factorable. Those are big numbers to try to factor, so. Yeah, let's just do, let's see. Yeah, I'm just going to do quadratic formula. So we got negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now we're solving for the width of a sidewalk. Width is a distance. what kind of number do you have to have when you're finding a distance? Or think about what kind of number would it not make sense for distance to come out to? Yep. Yeah, you can't have a negative, okay? Can't have a negative. So if we do have an opportunity where we get a negative, we're going to ignore that answer, okay? Because it wouldn't make sense in the word problem. Okay, we are subtracting a negative, so we can turn those into a plus. What's 4 times 150? 600. And what's 600 plus 1600? 2400. 600 plus 1600, yeah, 2200, yeah. So I don't think the square root of 2200 is going to come out to a nice number. Square root of 2200. All right, that comes out to about, let's just call it 46.90. Negative 40 plus or minus 46.90 divided by 2. One of these doesn't make sense. Is it the plus or the minus that we don't need anymore? Yeah. Yeah, because if you have negative 40 and you subtract something from it and divide it by 2, you're going to get a negative answer. All right, so let's see what that comes up to. All right, so we've got negative 40 plus 46.9 divided by 2. And the book said 3.5, so yeah, it's about 3.45 feet. That's the width of the sidewalk. Okay, so quadratic formula, definitely something you need to know. We'll talk more about it later on, but you might not have done it since algebra. Might come up in geometry, I'm not sure. But that's the quadratic formula. Any question on that one? So I think the picture, that's really the way to go. You really need a picture to kind of help you visualize what's happening. Yeah, just sign up for me. Okay. So another kind of problem that we look at in this section is called projectile motion. There's a formula for it. And our particular formula for projectile motion is based off using feet as the length unit and seconds as the time unit. If you do it in physics, you'll probably use meters and seconds. So this number might be a little different. You might see like a negative 9.8 if you're taking physics and you do that. And projectile motion is basically when an object is traveling and it's not powered in any way. It's not like it has an engine on it. You just like throw it, let it go, and then gravity kind of takes over. And the formula is negative 16t squared plus v sub 0 t plus s sub 0. Couple variables in there. T is time. V sub 0 is the initial velocity. So it's basically when you take the object and you throw it, how fast is it going the second it's released from your hand. S sub 0 is an initial height. So it makes a difference if you're standing on top of a building and you throw something versus if you're on the ground. If you already have 200 feet of height because you're on top of something, it's going to have more time to go further because it started up higher. Okay, but that's the formula for projectile motion. Okay, does everyone have the formula? Okay. Whether you shoot something straight up or you shoot it at a little bit of an angle, this formula for projectile motion still works. So we're shooting a rocket straight up from ground level, and the speed of the rocket starting out is 64 feet per second. Let's see if we can figure out the formula first. The negative 16, that's a constant. That has to do with gravity. So negative 16 never changes. Okay. What is the initial velocity in this problem? Yeah, Jack? 64 feet per second. And what is the initial height in this problem? Do you know yet, Edward? It's 0. It says ground level, so it has no initial height. So we don't need to put plus 0. We don't need anything. We can just leave our equation just like that. I wrote that down because now they're going to ask me to do something. They're going to ask me to find when the rocket will be 50 feet above the ground. Where would that 50 go in the equation up above? Would it go in for S of t or t? Yeah, then?
Well, it would go for S of t.
Right. S of t is a height. So that's where the 50 would get plugged in. Now I could do this problem just like we did the last one. I could take 50 and fill it in right there, bring it to the other side, get it equal to 0, and then use quadratic formula. Since we just did quadratic, I'm going to do this one different. Okay, I'm going to do it on the calculator. So I'm going to have 50 equals negative 16t squared plus 64t. But instead of bringing everything to one side, I'm going to use the calculator. I'm going to draw a picture and solve it that way. Okay, to solve it on the calculator, you want to take what's on one side of the equation, put that as your first graph. Take what's on the other side. You do have to use x for the variable. You can't use a t. So you always have to use x on the calculator. I'm going to put that in the second equation. And we're looking for where the equation on the left equals the equation on the right. Well, when you draw that, what does that mean? If you're looking for where two equations are equal, we're looking for where the pictures are equal. Yeah? We're looking for the intersection point. Now, before we hit graph, we're going to go to window. Let's think about x for a second. X is the time. What's the lowest value the time could be in this problem? Yeah. Yeah, we can't go lower than 0. Negative time doesn't make sense. So I'm not even going to look at it. The maximum time is how long it's in the air for. Well, I don't know. I'll just leave it at 10 seconds, and if it goes off the screen, I'll adjust it. Now, y is the height. What's the lowest height that this object could have? Yeah?
0.
That's also 0. What's the highest height? Well, I don't know. I'm going to guess. Maybe it doesn't go over 120 feet. If it goes off the screen, then I got to go higher. Now we're ready to hit graph. So there's my line representing 50 feet. There's my object being thrown. How many times does it look like it hits 50 feet? Yeah? Why? Why does it hit twice?
So it has to go up, then back down.
Right, it hits it on the way up, it hits it on the way down. So let's make sure we know what the question's asking. When is the rocket 50 feet above the ground? So that's going to happen twice. Second, calc, and then which option there do you think we want to use? Intersect. Yep. Now, the first curve can be anywhere on the blue. The second curve, it's off the screen, but if you press the left arrow, it'll come back on. It can be anywhere on the red. And now the guess is important, because the calculator can only give you one intersection point at a time. Okay, I'm going to do the one that's on the right. On your calculator, if you can keep moving the guess closer to the one on the left, I'll just ask somebody what you got in a second. Okay, but I'm going to leave my guess closer to the point on the right. I'm going to hit enter. And if I had used quadratic formula, that's one of the answers I would have gotten. 2.94. And there's another answer. On the way up, what's the time that it hits? 1.06. So if a problem doesn't say how to solve it, you can solve it algebraically or you can solve it graphically. But that's how you solve it graphically. Any question on that one? Yeah.
Can you go over again how you got the decimals?
How I got like the 0.94. So I got that from the,
Yeah, how did you get there?
oh, so second, calc, and then option 5. And it'll ask you 3 questions. Pick a point somewhere on the first thing. Pick a point somewhere on the second thing you want to use. And then the third thing it'll ask you for is a guess. You press enter each time. And then when I press enter, it gives me 2.94. Now, that's just an estimate that the calculator's doing. So depending on yours, you might get like 2.9354144. You might get a little bit different. But to 2 decimal places, you won't get anything different. Okay. Any questions on that? When does the object reach its maximum height? Well, there isn't any new work we need to put into the calculator. We can use what we already have. I want to calculate the max height. So I'm going to press second calc. And there's something new we're going to use here. Anybody have a guess which option we're going to use? Yep.
Maximum?
Maximum. Yep. Now, if I move my cursor left and right, notice which graph it's on right now. It's on the blue one. Am I trying to find how high the blue goes or the red? Yeah? The red. I'm on the wrong one. All I need to do is press the up or the down arrow, and it'll change from blue to red. Now, like doing an intersect, when you calculate a maximum, it's going to ask you 3 questions. The first thing says is left bound. that means they want you to take the cursor and put it somewhere that you know is definitely to the left of the maximum. So what we're going to do is we're going to give the calculator kind of an interval to look at. So put it to the left of the maximum, hit enter. It now puts a dotted line on the screen and it says, okay, I'm going to look between here and move the cursor to the right of the maximum. And then hit enter. Okay, so what we've done is we've given the calculator a section to look at. And the guess, it doesn't really matter. I just put the guess kind of close to where I think it is. Okay, and there's our maximum. So the question was asking us two things. What is the maximum height, and at what time does it reach that height? So we have to make sure we answer both. Yep. So is that like 2.0000001? Yeah, so I told you sometimes the calculator might give a slightly different number when you go out to like 7 decimal places, but that's okay. So first of all, what do you think the maximum height is here? The x value or the y value? Yeah.
Max height is 64 feet.
It's the y value, yep. So the max height is 64 feet. And we're not going to write that as the answer. We're going to round that. So basically, at what time does it hit 64 feet? How many seconds? Yep. 2. Yep. So max height is 64 feet. And that occurs at 2 seconds. Yeah. Question on that one? So I think we'll do one more from here, and then I think that'll be a good place. We're going to stop with 1.3 part 2 today. So last thing. So the last thing is what's called a piecewise defined function. Basically, a piecewise defined function is when you do 2 graphs on the screen at the same time. That's basically what it is. And generally, each graph is used under certain conditions. So I could say to you, all right, if you give me a value bigger than 0, I want you to plug it into formula 1. If you give me a value less than 0, I want you to plug it into formula 2. So it's depending on what your value is, you may have options of what formula to plug it into. A lot of the time, the domain is usually split up into 2 parts. If you have a number bigger than this, plug it in here. If you have a number smaller than this, we'll plug it in over there. Let me show you an example. So we're just going to graph this on the calculator, and then that'll be it. So this is an example where the domain is basically split at the number 1. If you give me a number smaller than 1, to get the answer for y, I want you to plug it into this formula. If you give me a number 1 or higher, to get the answer for y, I want you to plug it in to the bottom one. So which formula you use depends on, is your number bigger than 1 or is it smaller than 1? Let me show you how you type that in on a calculator. It's pretty similar to how we've been graphing everything. Okay? Except you got to tell it when to graph it. If you don't tell it when, it just graphs it over the whole screen. But I only want to graph the top one under that condition and the bottom one under that condition. So here's how you type it in. I'm going to go to y equals. You're going to put it in parentheses. 3 minus x squared. Just like that. Next to it in parentheses, you're going to put this condition. So we know where the x is. What you don't know is where the less than sign is. So I need to show you how you type less than. To type less than, press second, and then press the math button. That's how you get to your inequality symbols. And we want the fifth one down. Okay, let me do it again so you can see how to get to that symbol. So type in the function again, x cubed minus 4x. Once you do an exponent, let me show you how to do it if I haven't. It's the caret, it's this up arrow. Everything you type is going to stay in the exponent until you press the arrow key to come back down out of the exponent. So x cubed minus 4x. And we want to graph that when x is greater than or equal to 1. So x, second, math. That's how you get to the greater than or equal to. Greater than or equal to is the fourth one. So if we've typed this in the right way, it should graph what's called a piecewise function. It's going to be two graphs at the same time on the screen. Yep.
How do you get to the if again?
Second math is how you get to the inequalities.
Not the inequalities, the lower part of it, or the other parentheses around the inequality.
Oh, the parentheses
Is that just
symbols
another parenthesis?
are right there,
Is that just another it's right in the parentheses?
right above the 8 and the 9.
I didn't realize it was another regular parenthesis. Didn't realize it.
All right, let me hit graph. I'll do zoom 6 just in case I change my window. Notice all of a sudden the blue one just stopped. Kind of does this horizontal line. It shouldn't be there, but there's nothing I can do to fix that.
Where's the object?
Let's pretend it just looks like that. So it's graphing the blue one right up to the number 1. Does it include the number 1 in this top one or not include it? What do you think, Ben?
It's not included.
Does not include it. So if the calculator could really do this perfect, should have an open circle right there. Now it's graphing the bottom one from 1 and up. What kind of circle do you think I should have on the red one? Closer. Yeah. So we can practice doing more of those later, but that's the last thing I wanted to show you. And the homework. I'll make sure it's in the video, but if you want to copy it, you can. It's just page 31.